Hello everyone. In the previous classes, we had talked about the polynomial, identification of polynomial, which are polynomial and which are not, the value of polynomial given at this certain point, that is what is the value of that polynomial if the value of x is given. Then we had talked about the zeros of polynomial. In previous class, we had seen a gist of the remainder theorem. So today we'll continue about the remainder theorem. What is remainder theorem all about is, and how to verify the remainder theorem or verification of remainder theorem also we'll talk about. So uh, as we had seen this question in the previous class, that px is equals to 2x square plus 7x plus 6 and gx is equals to x minus 2. So remainder will be p of 2, that is 2 square plus 7 into 2 plus 6, that is 8 plus 14 plus 6, that is 28. So the remainder theorem says that px be any polynomial of degree greater than or is equals to 1 and a be any real number. If px is divided by a linear polynomial x minus a, then the remainder is p of a. That is, this is called the remainder theorem. So today we'll talk about the remainder theorem again. That is what is the remainder theorem all about, how to identify the remainder theorem, how to apply the remainder theorem, and the justification or verification of remainder theorem as well. So as this is the one of the example, now we'll discuss a few more two more examples, and then we'll talk about the remainder theorem proof. So let's say px is equals to a polynomial of degree 3, that is 3x cube plus 11x square plus 7x plus 3. This is the polynomial of degree 3, that is the cubic polynomial. And gx is a polynomial by which we are dividing px, that is x plus 3. So we are dividing 3x cube plus 11x square plus 7x plus 3 by a linear polynomial x plus 3, that is px by gx. Now we need to find remainder and quotient. If the quotient and remainder both asked, we need to apply the long division process only. But in case if it is only remainder is asked, we can directly apply the remainder theorem. So here, first we need to find out the remainder only. So to find out the remainder, we are doing the long division process, which we had done, which we had learned about the long division process in the class 8 also. So we are dividing 3x cube plus 11x square plus 7x plus 3 by x plus 3. Now the first term is 3x cube, and here the first term is x. So 3x cube by x will give you 3x square. This is the first term of quotient. 3x square into x will give you 3x cube, and 3x into 3 will give you 9x square. If you are subtracting, we'll change the sign of 3x cube and 9x square. 3x cube minus 3x cube will become 0, and 11x square minus 9x square, this will give you 2x square plus 7x and plus 3 as it is. Now the first term of new dividend is 2x square. We'll divide 2x square by x. So we'll get 2x as the second term of quotient. Now 2x into x will give you 2x square. 2x into 3 will give you 6x. Now we'll change the sign of 2x square and 6x, negative and negative. 2x square minus 2x square 0, and 7x minus 6x will give you x plus 3. So here we have the next term is x, the first term of dividend is x, and here also the first term of dividend is x. So that will be one time. x1s are x and x3s are 3. We'll subtract this x and 3. X minus x 0, 3 minus 3 0, and we'll have the remainder as 0. So here we can see the degree of this 0, or the 0 can be written as 0 into x raised to power 0, which is a constant number, and x plus 3 is the power is 1. So we have the quotient 3x square plus 2x plus 1, and remainder is equals to 0, which is here. So we have a degree of remainder as 0 and degree of divisor is 1, that is x plus 3. Now what? We need to apply the remainder theorem as well. So we'll try to check whether that using the remainder theorem we'll get the same remainder or not. So we are dividing 3x cube plus 11x square plus 7x plus 3. As here also you can say we had divided 2x square by x minus 2. Here the degree was 2 and the remainder's degree was 0. Here also the degree was 3, but the remainder's degree is 0 here as well. We are dividing it by x plus 3. and as per the theorem this is x plus 3. But if we have a look on the theorem part, it is given that if we divide the polynomial by x minus a, a linear polynomial x minus a, so we need to equate this x plus 3 by x minus a. This x plus 3, if we equate it with x minus a, we need to find the value of a here. So if we'll have a look to find out the value of a, we can write this x minus 3 while dividing p of x as a is equals to minus a is equals to 3. This will give you a is equals to 3. We can write x plus 3 as x minus minus of 3. So if I'll writing this x is minus 3, x plus 3 as x minus minus of 3, this will give you x minus a. When you equate it to x minus a, the value of a seems here is a is equals to minus 3. So we'll find out the value of polynomial x at p x is equals to minus 3. That is p of minus 3. Now we'll substitute the value of x as minus 3 in the given polynomial after equating the given polynomial. If it is given in the plus form, we take the minus minus sign common, and x minus minus of 3 will be x minus a. On equating, we'll get a is equals to minus 3. Now what we'll going to do is we'll find out the value of given polynomial at the given value of a, that is minus 3 here. So we are going to substitute this minus 3 in the given polynomial, that is 3x cube. So 3x cube will give you 3 into minus 3 cube, as x is equals to minus 3 here, plus 11 x square. Again x is equals to minus 3 here, so it will write minus 3 square, plus 7x, that is 7 into minus 3, and plus 3 again. Now this minus 3 cube, as the power is odd number, that we get the negative sign first, because the power is an odd number. In case of minus sign placed to the power an odd number, we'll get the negative sign. This is minus 3 3s are 9, 9 3s are 27, 27 into 3 will give you 81. Now minus 3 square, this will be positive 9, minus 3 square is positive 9, and 9 into 11 will give you 99. Now 7 into this plus sign, 7 into minus 3 will give you minus 21, so it will become minus 21 and plus 3. Now we'll add this 99 and 3. This 99 plus 3 will give you 102. This 99 plus 3, that will be 102. This positive positive we are adding, and negative negative minus 81 and minus 21. This is also is equals to 102 only. Now 102 minus 102 becomes 0, because this 102 positive and negative will get cancelled. So here also we'll get the same remainder using the remainder theorem. Here you can see in the remainder theorem we have substituted the value of p minus 3, and in this case we got the value by using a short method. Just by substituting the value of x as minus 3, we'll get the remainder directly. So this is the smallest method to find out the remainder. If it is asked in the question to find out the remainder only, we'll directly substitute the value of given polynomial. We can get the value of x after substituting x plus 3 is equals to 0. If you substitute x plus 3 is equals to 0, this will give you x is equals to minus 3. And then you can substitute the value of x. So we can equate the divisor with 0, that is x plus 3 is equals to 0. Then x is equals to minus 3. We'll substitute the value of x is equals to minus 3, and we'll get the answer directly using remainder theorem. Though in both the cases the remainder is same, so we can apply any of this method to find out the remainder. Now we'll discuss one more example to find the remainder using remainder theorem, and then we'll have a proof of remainder theorem. So if we apply the remainder theorem, that is, we'll do both the things, long division method as well as the remainder theorem, to check whether the remainder is same. Although if it is asked in the examination that find out the remainder, you need to find the remainder by remainder theorem only, because the remainder theorem is the smallest process, simplest process, in which the possibilities of error is very less. So we'll take the another example, that the polynomial px is equals to x cube plus 2x square plus 2x plus 1, x cube plus 2x square plus 2x plus 1. Here This is the cubic polynomial, and gx is a linear polynomial of degree 1, that is x minus 1. So we'll do the long division process first. When we'll apply the long division process, we'll divide x cube plus 2x square plus 2x plus 1 by x minus 1. So we are dividing this px by gx, that is x minus 1. Now the first term of this x cube and x, this will give you the first term of quotient is x square. So this will be x cube, x square into x, and x square into minus 1 will give you minus x square. Now we'll change the sign, minus and plus. X cube minus x cube get cancelled. 2x square plus x square is 3x square plus 2x plus 1. Now the first term of new dividend is 3x square, and here the first term of divisor is x. The next term of quotient will be 3x square by x, that is 3x. So 3x square into 1 into minus 1, minus 1 into 3x will give you minus 3x. Now we'll change the sign of minus 3x square, and minus 3x will become plus 3x. 3x square and 3x will be cancelled. 2x plus 3x will give you 5x and plus 1. Here 5x divided by x, the next term will be 5x divided by x, that is 5 only. So the quotient next term is 5. We'll multiply 5 into x minus 1, that is 5x, and 5 into minus 1 will give you minus 5. Now we'll change the sign. Minus 5x plus 5x is cancelled. 1 plus 5 is 6. So this is what your remainder is. This is 6 is your remainder. The quotient is x square plus 3x plus 5, and remainder is 6. After dividing px by gx, we'll get the quotient is x square plus 3x plus 5, and remainder r as 6. Now we'll apply the remainder theorem here to check whether the remainder is same in both the cases only. Then for further proceeding, we'll apply the remainder theorem only for further questions. So we'll equate with x minus a, that a is equals to 1 here. X minus a is equals to x minus 1. Simply a is equals to 1. We'll substitute the a is equals to 1 in the given polynomial, that is 1 cube plus 2 into 1 square plus 2 into 1 as 2x plus 1. So x cube, that is 1 cube, is 1. 2 into 1 square, 1 square is 1, into 2, that will be 2. 2 into x, that is 2 into 1, 2, and plus 1 as it is. Now we'll add 2 plus 1, 3, 3 plus 2, 5, 5 plus 1, 6. So we'll get the remainder directly, 6 in 2 or 3 short steps. So here we get the same remainder here by the remainder theorem, and here also we have the same remainder, 6. So it is quite easy to find out the remainder using remainder theorem. Just put the value of x. Now we'll have a look on the proof of remainder theorem. The proof of remainder theorem is based upon a simple concept of division, that is dividend is equals to divisor into quotient plus remainder. So the remainder theorem says let px be any polynomial of degree greater than or is equals to 1, and let a be any real number if px is divided by a linear polynomial x minus a, then the remainder is p of a. This is called the remainder theorem. We'll prove this. We'll take a polynomial px which is to be divided by a polynomial gx, and then we'll have some quotient and some remainder. So we'll go to the proof of remainder theorem. It is said if a polynomial px of degree greater than or is equals to 1 is divided by a polynomial gx, so we'll get, after solving it, we'll get a quotient, and then we'll get a remainder. So px by gx, after applying this division, after processing this division, we'll got a quotient and remainder. Let's say if we have 100 by 2, 101 by 2, we'll get a quotient is 50 and remainder is 1. So in this case, the quotient is 50 and remainder is 1, which give us the remainder theorem, that is 50 into 2 plus 1 is nothing but 102. If we multiply this 50 and 2, that will give you 100. 101 plus 2 plus r is equals to 1 will give you 101 again. That is Px is equals to nothing but Gx into Qx plus Rx. Px is equals to nothing but Gx plus Qx, Gx into Qx plus Rx. That is dividend is equals to divisor into quotient plus remainder. So we have Px here, Gx, Qx and Rx. That is dividend, divisor, quotient, remainder. Now this Px is nothing but Gx. What is the value of Gx in the given definition of polynomial? It is divided by x minus a. So Gx is nothing but x minus a plus into Qx plus Rx. Now, as the degree of this x minus 1 polynomial Gx and degree of this Rx, we'll talk about the degree first. So, as x minus 1 have degree 1 over here, the maximum power of dividend is 1. So, divisor is 1. So, reminder's power should be less than 1, that is x raised to power 0. That is, this Rx will be a constant number because we have a linear polynomial in divisor. So the remainder will be a constant number that is equals to R only. So instead of Rx, we can write R because the power of divisor is 1. So the power of remainder or the degree of remainder should be less than 1. And what is less than 1? It is 0 only. If it is more, if we'll talk about less than 1, 1 minus 1 will 0 because we have certain conditions of polynomial that the power cannot be less than 0. So we could have the power of x as 0 in case of remainder. This remainder will be R only. Now Px is equals to x minus a into Qx plus R instead of Rx because this is a constant number. Now x minus a, so we'll substitute x is equals to a as the given condition of remainder theorem. So we'll substitute p of a. P of a will be instead of x, I can write a only. That is a minus a into q into, instead of x I should write a over here. So q into a, that is q of a plus r. As r a minus a is 0, that is a minus a into qa will become 0. A minus a is 0, 0 into something is 0, so we're left with r only. That is p of a is nothing but r. This is what the remainder theorem is. If we are dividing a polynomial px of degree greater than or is equals to 1 by a linear polynomial x minus a, then the remainder will be p of a. So here we can prove that we had shown this, that the remainder in this case, that is remainder r is equals to nothing but p of a. So we had proved the remainder theorem here. If we are dividing any polynomial px of degree greater than or is equals to 1 by a linear polynomial x minus a, the remainder is p of a. P of a. If we are dividing it by x minus a, the remainder will be p of a. If we are dividing by x plus a, the remainder will be p of minus a. If we are dividing it by x plus a, the remainder will be p of minus a. If we are dividing it by x minus a, the remainder will be p of a. So this is what the proof of remainder theorem. The remainder theorem says on dividing two polynomials, one whose degree is greater than or is equals to 1 and the one whose degree is 1, that is linear polynomial. If we are dividing two polynomials of degree greater than or is equals to 1, we'll get the polynomial, we'll get the remainder as nothing but, if we are dividing it by x plus x minus a, the remainder will be p of a. If we are dividing it by x plus a, the remainder will be p of minus a. This is what all about the remainder theorem. In next classes, we'll talk about the proof of remainder theorem and properties factor theorem. So in the next class, that is tomorrow, we'll talk about the next concept, that is value of polynomial. We'll discuss about the questions of values of polynomial. That is exercise 2.2 of NCERT. Thank you very much. Have a nice day.